And this example, the European Space Agency actually used this a functional, it's not a prototype, it is a production one that was actually used as part of the liquid rocket engine, and that was completely 3D printed and used. And here are the spec on that. You can Google it and you can find that. I think India is ready and prime. It is in its prime state to get it to the next level. But our task from schools and colleges in India is to promote by using a functional, a couple of 3D printers that you can build it inexpensively, and say college students can help high school students. High school students can help middle school students and elementary level school students. And similarly, the professors and expert faculty members of universities can help their affiliated college faculty members, and they can interact with inspiring and introducing, giving in the form of giving workshops, etc., to the high school, middle school, and elementary school teachers. So from ground up in India, we can build innovation culture and using a hands-on applied STEM, science, technology, engineering, and math type of a learning model. I hope it makes sense, and it is very much doable, but the only thing is that Indian institutions have to support it. I think we are ready, and the government, I believe, is trying to do everything. And let's talk about another vertical market where biomedical devices, say I was in San Jose in the Bay Area. There is a specialized company that uses, say, when you are a medical student and you are going to the anatomy lab, and the actual dead bodies, cadavers that are being opened, and it smells really bad when you go into an anatomy lab, and you actually get to touch and feel and put that body back, and you become a doctor. What about that? So that at one point you actually need that, but before that, you can actually use a 3D printer to create a model of, say, your heart, or a specific type of valves in the different sections of your heart, and then you can specifically zoom in and focus and highlight the different parts so that it is easier for them to learn. And so you can make medical dummies, medical dummy body parts, or even a functional body part that can be created. And currently, as you probably have read that in the newspapers and science journals and magazines, these are actively in the works that are being done. What about Spacesuit? Spacesuit is extraordinarily expensive. It used to be very difficult to manufacture, but these days, with the 3D printers' help, we are able to custom measure that astronaut, and then print all the necessary parts and weave them together and create that custom suit. There's a case study. There's a company called, a bunch of MIT students got together and they formed a company called Desktop Metal. They are using a special technology where, similar to FDM, and they are able to print one-off parts with enormous time saving benefits and material strength benefits. In every aspect, they're able to do that. So I told you how innovation that seemingly sounds silly, um, but the sillier the project is, not very serious. Oh, like a mechanical engineering professor in India would say, oh, just focus on this special electrical car engine or motor that you wanted to do. And they will directly go in there and work all of the algorithms and the logic behind it, but without ever touching that, actually making a prototype in the, first off. But whereas in the US, the culture is, I told you at one point, is a garage-based culture. So you first start with failing, making things and failing a few times, so that from the beginning you're focusing on quality, and uh, your success in making innovative products are uh, higher or high. So there was one project that was done in MIT that I got to see. A student, many times. Let me go to video, um, because right now I'm talking to the screen, hoping that I'm actually being audible, etc. So. Um, the problem in that project, that innovation project, was um, many a times you feel like screaming, right? Um, but you cannot scream because it is offensive to others. Maybe you're in a public place. Sometimes now, even with the COVID, you try to control your sneezing or coughing or blowing your nose, etc. So this girl in MIT Media Lab wanted to create a screaming machine. And what is that screaming machine? She thought the problem, like I was describing, whenever you feel like screaming, you should be able to capture the scream in a bag and then let it out at an opportune time and place. So she created a kangaroo-like pouch. Um, Thank you, Dr. Polymer. Um, so like a kangaroo, the animal from Australia, she created a custom pouch, and she used 3D printers to make a lot of the parts for that, and also used Arduino, the open source hardware, and started the project. And whenever she felt like screaming, she'll open the bag and she'll scream into it, and then close it. And it had that all of the mechanisms in that product. Then later, whenever she found the right time and the space where it's not going to bother others, and she'll push a button and it'll open and the scream will come out. Yeehaw, whatever scream that is, that the screaming machine, that's what it does. Now, does it have a commercial value? But it has a cool factor. It is fun. Just imagine somebody captured somebody's scream and then it lets it out, and you're able to control the time and space for that. And the amount of science and technology, engineering, and the promotion of innovation that happens in that project is huge. Okay. Um, so that being said, I would like to open up the presentation for questions and answers. You can either type in your question, um, or you can unmute yourself and ask the question, and somebody can moderate that.
So, how can be the effectiveness of the normal FDM filters available in Amazon and Flipkart is there? Whether they are useful to purchase and to make as a teaching material?
So I believe your question is when you buy a printer from Amazon, right? A
Right.
typical FDM printer from Amazon. And I heard that clearly. And after that, what happened?
Can we use it as for teaching purpose? That is to teach how to make the 3D printing and 3D printing process to graduate students.
Yes, my recommendation is yes, start with that. Um, and I'm sure it's going to be made in China for sure, because they make everything for the whole world, even now. Start with that, get a couple of 3D printers, and then I'm an Indian. I love India, and what I would like to do is what the Chinese did always. What did they do? Um, they took pictures and then they recreated everything. And now they are in a place where they don't have to take pictures and they have started making high quality products. So we missed that boat. I mean, we tried at one point in Mumbai, and like when I was 20, 25 years old, it happened actively. But the duplicate market, like Burma Bazaar and all those places, got inundated. But right now it is our turn. Yes, buy a couple of 3D printers, like I said earlier, and then start making, let your students make them. In fact, you just buy two and make them disassemble one and take it apart and then make them put it back. And then these guys will be ready to make their own 3D printer using local materials. And I have seen it. I have seen your college students do that, and I was very proud of recalling that experience. And that is one of the things that we did, and when we hired the interns from your school.
Next one, sir, from my side.
Yeah.
What are
Uh,
the research opportunities in 3D printing, especially polymer 3D printing? Because it is saturated, I think. Is there any opportunity to do research further in this polymer-based 3D printing?
uh, Dr. Balmorgan, the voice is kind of mumbled. Um, uh,
Can can you hear that, sir?
yeah, if you can speak up, maybe
Okay, sir.
speak up a little.
I will
Yeah,
again ask.
yeah.
What is the research opportunities in polymer-based 3D printing? Because most of them are tried, I think it is not fully established. Is there any opportunity to explore more? That is to do research in polymer-based 3D printing?
I actually knew a professor that I worked with in SRM University, and his focus was on optimizing the polymer technology for 3D printing. And he was also working with the students using recycled, like plastic waste products everywhere, collecting them and then uh, repurposing and making 3D printable, like pellets first, and then later the pellets will become extrudable wire spools. And that was the research that he was doing. So my answer is yes. What I would do, again, that is a nice project. Since we are still using a lot of plastic and waste and stuff, and I would strongly encourage having a bunch of students do research and have a competition around that. I can even support such competition through some sort of an award at the end for good ideas or good say prototypes that they can make.
So when I want to do research in the polymer 3D printing, what would be the range of the machine to be purchased or procured? for this type of research, because we are academicians. Mostly we are concerned about research and teaching. So what is the range of the machine is required for effective research in polymer?
Yeah. I'm sure we can have a separate conversation around this.
Okay, sir.
I can even connect because I'm not I don't go into, I'm at the managerial level. So I'm not able to go into the lot of technical aspects of it.
Okay, sir.
Thank you. Anybody else?
One question.
Yeah, I have one doubt.
Yes.
Hello, is it audible,
Yes.
sir?
Yes. Surya Varman, right?
Yeah, sir.
Yes.
For a student community, which type of printer you prefer most, sir? Whether FDM based or SLA based, which one you prefer for a student community, please?
Start with either one will work. We have tried in the beginning. It's both are similar approach, similar concept, so it'll work. But FDM is less expensive, right? SLA is a little bit more expensive. What is the current market availability there? I believe Creality printers are the ones that are being flooded into the Indian market, right?
Yeah, sir. Most widely, FDM is available in everywhere, but other type of technical method or deposit or jetting type of printers are not.
Yeah. Yeah, so if you don't have any, I will put priority one. Your first will be FDM, and then go for stereo approach, where it cures liquid polymer in a tub and then extrudes from that. Because it's more expensive. Obviously, the technology is more involved in that. We have worked with the local university here on that. But FDM is my first step that I would do if I were you.
Yeah, sir. Thank you.
You're welcome. Anybody else? All right. So Dr. Balamurgan, if there are no other questions, I wanted to thank all of you for this opportunity to share my experience and knowledge.
Sir, I have one question, sir.
Yeah, yes, Saravanan.
Sir, is there any chance to print complaint mechanism material by using 3D printer, sir?
What mechanism are you talking about?
Complaint mechanism, sir. Complaint.
Can you give me an example?
Example. Before, at the starting of this presentation, you have video on playing, sir. You played a video, that hand movement video.
Oh, yeah, yes.
It's also an example of complaint mechanism, sir.
Okay, I'm not sure that word that you are talking about.
Okay,
Yeah, so there is a lab in New Hampshire in the U.S. They focus on. Are you talking about complex structures?
sir, it's a flexible mechanism, sir. Complaint mechanism is also otherwise called flexible mechanism.
Flux. Oh, okay. Yeah. So you have to print modular parts, and then you have to stitch them together. It's a little bit laborious. So what we try, you're a humanoid robot, right?
Yes.
Robot that can walk. We have actually done that. It'll be unwieldy. In fact, we took a Hollywood actor and then recreate that actor, facial structures and all of this. But very, very involved, very, very involved to do that. But you have to modularize every segment and then put them together through some sort of joints assembly system.
Okay, sir. Okay, sir. Thank you, sir.
Yeah.
Sir, one of the participants asked me permission to speak with you. Can we allow him?
Sorry. What was the comment there? Comment or question?
Max Car Hero, can you please speak? Unmute
Yes,
yourself
sir.
and speak, please.
If possible, I can answer that question, sir.
Sure. Yeah. Go
Last
ahead.
question, sir. Sir, actually, the complaint mechanism comes under the topic design for additive manufacturing.
Okay.
Parts for in the process of additive manufacturing. This process helps us to create mechanism inbuilt in the design itself. For an example, we got a cloth clip. Cloth clip components majorly, the top part and the bottom part and a metal spring. So by complying mechanism, we can create an internal stress so that we can simply print a component and it can work like a cloth clip. And this mechanism is used in satellite navigation system, where we have nozzles, right? So in order to reduce the amount of electricity that we use in satellites, we can implement this compliant mechanism, and with one motor, we can control the X and Y direction of the motor. So this is a very good work. I couldn't remember the university which does this, but in design for additive manufacturing, this topic is a very interesting topic that we can develop a lot of components in this regard. And
George,
when we use the printer, we got the pass function also, where we can add another infill so that we can make those parts also work in a better way.
Beautiful example that you gave. Okay, so George Mason University, for example, the muscle in your heart, they're specializing in biomechanics. It is used there quite a bit, but the challenge is the material that you use for that. They're even specifically culturing those tissues, and then those are tissue cultured and replicated in the lab, and then that gets extruded to make that muscle, and they are testing those in the medical world and biomechanically, especially biomechanical. And thanks for adding that information. Now it makes sense to me. Yeah.
Sir, I am Santosh Kumar, sir. I have one doubt, sir.
Sure.
Sir, which type of 3D printers are used to build a human organ, sir? Is possible?
Again, it is at the R&D level. Like I said, George Mason University, they are working with pig's heart, and what they are taking those tissues from the heart of the pig, and they are tissue culturing it and then growing it in the lab, and then they are using that with special biomimicking materials to do that. It's at infant stage right now. That is my understanding. But it is custom. The material itself is custom manufactured in order to make that.
Okay, sir. Thank you, sir. Sir, which type of 3D printers are used, sir?
Again, those 3D printers are specialized 3D printers.
Okay.
It
Okay,
wouldn't
sir.
fit into any of these categories that we are talking about currently. See, 3D printer technology has been there for a long time. So the patent licensing requirement by 3D Systems, that is the main company that owned it, that expired, and then it opened up the whole world of everybody trying that, and then open source folks got in and popularized it. So, but a lot of secret work that is happening, and they are not being published, and they are not even available on the internet because these funds are funded by pharmaceutical companies, and American pharmaceutical companies are closely guarded. It's a multi-trillion-dollar industry across the world, and they are betting on making these specialized 3D printers. I'll tell you, HP, that makes your paper printers, and they are putting in billions of dollars into making 3D printers becoming a mass-produced, consumer-consumed type of technology. And they are going to sell little cartridges where you can actually, the printers will behave like regular paper printer. So, but they are not publishing until it becomes a readily commercially viable product. But we know that they are doing that research as we speak.
So, thank you, sir.
Yeah.
Thank you very much, sir. Very valuable information you are giving. So thank you for giving this very informative presentation for us. Thank you, sir.
Ganesha Balamurugan, this is Manimaran.
Yes, sir.
Hello.
This
is Manimaran here, sir. Is it possible to print biodegradable plastics product without it in the economical way?
So the one that say the U.S. schools are very much into health, right? So the bioplastic material is what? Which one is that? SLA, the material that I showed. All these print materials that we use here. Let me bring that. So this uses the material that is an acid from a plant. It is an acid-based material, and this is closed environment, air conditioned. When it is printing, it doesn't cause any bad smell, does not create any fume, no health issues with this. So when we have students come to the lab and learn and print, we are only allowed to use this. Any other type of anything other materials, you're not allowed. Okay.
Thank you, sir.
Yeah. All right. Very good.
Yes, sir, I have one more question, sir. This is Vetri Selvan, sir.
Yeah.
Will a 3D printed object superior in strength when compared with conventional products, sir? What about in strength perspective, sir?
So that is a lot of people are doing their PhD level research on tensile strength, malleability, ductility, those elemental analysis type of things. And that is where every university, major universities are focusing on material science. Material science that will research and develop the materials that are going to give optimal strength needed in specific temperature, right? For example, if you are putting a 3D printed material on the space station, on one side, it is facing one side of the the space that is about minus 200 degrees Celsius. On the other side, it is plus 200 degrees Celsius. So one side it is almost melting, the other side it is freezing, and the material has to withstand extreme such variation, temperature variation. So that is the reason material science is one department where a lot of active research is happening in the US, and funding is also getting pouring in. HP, like I said, how you can make 3D printers that can be mass consumable, consumer friendly, like regular paper printer, and where's the money being spent on the research? Material science. So you take the elements in the periodic table and make a concoction. Remember, we were making trying to make gold out of a bunch of plants. சித்தர்கள்லாம் சொல்லுவாங்க, சித்தர் மெடிசன்லாம் பண்றது அந்த மாதிரி. The material science is hot right now, and if I had the money, I would definitely go to that, but it is an expensive thing. Private companies, even very big companies, in India cannot afford it. It has to be a frontier research. Frontier research means start with theoretical fundamentals, understand the elements in the periodic table, and then how to make a concoction, and then how material science R&D will be able to filter that out and say, oh, you make these three elements in this formula, then you can print a specific component that'll work in X, Y, and Z temperature condition and variability.
Thank you, sir. And I have one more question regarding actually business point of view.
Yeah.
And what is the scope of doing business with 3D printer? Is this the right time to invest on 3D printers to do certain business in Indian perspective, Indian market?
Yeah, I was actually thinking about making, you have malls, shopping, big supermarket. Is that in Chennai? There's a place called the Phoenix Mall. In Pondicherry, there are some big multi-level places. And now there is a consumer market for, mehendi, the henna, right? Henna?
Yes, yes.
Mardani.
Yes.
So I would like to make a 3D printer that'll apply Mardani in beautiful designs. They can draw their own picture, what type of thing that they want. Right now, they had to go to what is that place? The popular ladies only places are there. Women go there and get their mehendi done on their palms and on their feet. But 3D printer can do it. They just have to go, like they go to a salon and you get your makeup done. And similarly, the 3D printer can do that. So Indian market is ready for that. Some of your students should start doing all of these, including your dosa printer. Like we have your pancake printer. I think it'll become a nice micro loan. Banks can provide loans, but you have to just standardize it and then provide ongoing technical support, because these things are they need constant maintenance, because it works with temperature, it melts stuff, and then especially the nozzle gets dirty, and that needs to be maintained, like I said before. So business opportunities are plenty to me. It's not, you're not going to have a precursor, right? I mean, precursor meaning you're not going to be already seeing an existing business. You're going to create a new business and then create that new market. So you will be a trailblazer and pioneer in doing that.
Thank you, sir. Thank you.
And it is not expensive either to do that.
Thank you very much, sir.
Thank you, everybody. I enjoyed talking to all of you.
Thank you, sir. You should. You also.
Thank you.
One more, is it?
Okay.
So
Thank you, Mr.
yeah. So then I will disconnect, and thanks everybody.
Yeah, one more minute. Thank you, Mr. Kumar Ramjayam, for having spent your precious time with us this day, especially the time difference between US and India. If you
Yes.
are an early bird timer, you would have gone for sleep by this time.
Yeah,
So,
yeah.
thank you very much for having spared your time, precious time for us. Your lecture was fully informative and educative, and no doubt that all the participants would have been benefited. Thank you once again. Thank you very much.
Thank you.